sklearnmetrics, median absolute error. Description. The median absolute error (MA) is a robust metric that measures the average absolute difference between the predicted and actual values. It is less sensitive to outliers than the mean absolute error (MA) and provides a more representative measure of the typical prediction error. Inputs. Y true, the true values of the target variable. This can be a 1D array or a 2D array, where each row represents a sample and each column represents a different target variable. YPRED, the predicted values of the target variable. This must have the same shape as Y true. Outputs. Median absolute error, the median absolute error between the predicted and actual values. This is a single floating point number. Steps. Calculate the absolute difference between each predicted value and the corresponding actual value. Calculate the median of the absolute differences. Metrics. Robustness (MA) is robust to outliers, making it a good choice for datasets with potential extreme values. Interpretability (MA) provides a clear and intuitive measure of the average prediction error. Visualization plots. Scatter plot. A scatter plot showing the predicted values against the actual values, with the MA highlighted. This plot can help visualize the distribution of prediction errors. Residual plot. A plot of the residuals predicted values minus actual values against the predicted values. This plot can help identify patterns in the prediction errors and assess the model's performance. Fine-tune parameters. None. The MA metric does not have any tunable parameters. Uncertainty methods. Confidence intervals. You can calculate confidence intervals for the MA using bootstrap resampling. This can help quantify the uncertainty in the estimated MA. Challenges and fixes. Challenge 1. The MA metric can be biased towards the median of the target variable, especially if the data is skewed. Sample use case that resulted in challenge 1. A dataset with a high number of outliers might lead to a MA value that is not representative of the majority of the data points. Fixes to challenge 1. Consider using other metrics, such as the mean absolute error (MA), or transforming the data to address the skewness. Challenge 2. The MA metric does not account for the scale of the target variable. This can lead to misleading comparisons between models with different scales. Sample use case that resulted in challenge 2. A model predicting house prices might have a lower MA than a model predicting the price of a cup of coffee, even if the second model has better predictive performance. Fixes to challenge 2. Normalize or standardize the target variable before evaluating the MA. Alternatively, consider using a scale invariant metric, such as the normalized MA,